All right, this is going to be AP Calculus, Notes 4-3. We are on tangent line approximations. So where are we in our unit guide? 4-3 is here. We have 9 lessons in this unit, and we have quite a bit of tangent lines, so we're still in standard J. All right, so we have the setup written down already. Let's knock them down. So if the line 4x plus 2y equals 4 is tangent to the curve y equals 2x squared plus k, then k is what? So let's go ahead and dissect this problem, and then we can go ahead and start solving it. So I have a line here. This line is going to be tangent. This means this whole thing, we need to analyze the slope of this line because that's going to be the slope of the tangent, right? So let's go ahead and say that whenever you see the word tangent, let's circle that, tangent, or underline it, tangent, that means we're going to do a d dx. We need to find a derivative. Whenever I see the word curve, you need to be thinking, okay, well, that's the actual function that we're talking about.
Can we write that on the side?
So that's what I'm about to write. I have the setup over here. So every time you see tangent,
Is it okay, like, when you do those notes, like, I usually don't put it on the side because my side's so, like, skinny.
that's fine, yeah.
You know, like, I just put it, like...
Every time you see tangent, so you need to think one of two things. You can think of d dx if you like that for the derivative. I think more commonly, we've already been using this more, f prime. So as soon as you see tangent in any problem, not just for unit 4, but anytime you see this on the AP test, tangent means find derivative. Okay, what does curve mean? Every time you see the word curve, yeah, you need to think of, okay, that's the function that I'm actually looking for. That's our f. The other note that I want to give us, and I haven't started analyzing the problem yet, but whenever I am given this form, just out of curiosity, do any of us girls know what this form is called?
This girl does. No, I'm just kidding.
Point slope form.
Nope, it's not in point slope form. There's no y minus something.
mx plus b.
This is not mx plus b. This is called standard form when you have something x plus something y equals a number. It's not really important, but anytime you have a form that's not in y equals mx plus b form, it's going to be really hard to figure out what the slope is. So let's get it into y equals mx plus b. So just kind of our general note. Get into y equals mx plus b form to find a slope.
Curve, yeah.
Because remember, when we're looking at a graph of f, what is f prime going to be? Is that going to be height, slope, or concavity? I'll repeat the question. When we're looking at a graph of f, this is a graph of f. What is... Oh, I'm forgetting the question now. What is our prime going to be? What is f prime going to be? Is it going to be height, slope, or concavity?
On what graph again?
On a graph of f.
F prime is going to be slope.
Slope, right.
Wait, why did you have to repeat the question?
Because no one was answering aside from Joy.
How many people are supposed to answer?
Everyone.
Slope.
Or the majority of us. All right, so
Slope.
let's go ahead and solve this thing. So let's deal with the tangent first. So the tangent line was this line right here, because we said this line is the tangent line. So the tangent line was 4x plus 2y equals 4. I need to figure out what the slope was for this line. So let's go ahead and rearrange it. What are we going to do? Just shout out what to do.
Wait, when you write tan, you mean tangent, right? Not like...
Yeah, tangent.
Okay.
Subtract by 4x and divide by 2.
Yep, subtract 4x, divide by 2. So when I subtract 4x from both sides, I'm left with 2y is equal to 4 minus 4x. and then divide everything by 2, and I get y equals, I'm going to put the x first over here, so it's going to be negative 2x. Whoa, that x was a little bit big. Negative 2x plus 2. All right, so our slope was, our y prime, our slope here was
2. Negative 2, sorry.
negative 2. You can either take the derivative or you can just look at this value in front of x. It's the same thing.
Because in mx plus b, m equals slope. That's right.
Yeah.
2.
And I'll repeat that just in case the video didn't pick it up. In y equals mx plus b, this m right here, that's our slope. The negative 2 is our slope. Perfect. So we've analyzed our tangent line. And by the way, tan, T-A-N, is the shorthand for tangent, even if I'm taking the trigonometric function. Let's look at the actual curve. So the actual function. So we'll say this is the curve. Okay, I can spell curve. So what was our curve? It was this thing. Let's copy it down. That was y equals 2x squared plus k. Okay, so we also need to find the derivative of this, because the derivative, we need to set these two equal to each other. I know I'm trying to find where the derivative is negative 2 for this function. So let's take y prime. The derivative is what?
4x plus k.
K, think of this as like 2. So plus 2, that would go away.
So just 4x.
Just 4x. And now look here, we have a y prime equals negative 2 and a y prime equals 4x, which means I can substitute this negative 2 in for our y. So we can say, we're going to sub in right here. We can sub in our negative 2. Okay, I'm going a little bit too fast. I need to back up and understand this problem. This is the only problem that we're doing for our notes, and then we're done. Let's think about what we just did. We just found that the tangent line has a slope of negative 2 at this certain point. So we're trying to figure out where our derivative of the curve has a slope of negative 2. That's why we're plugging in our negative 2 into our y prime. We know that the slope is negative 2. This y prime means slope. We plugged in negative 2, and then we're going to find the x coordinate where our slope is negative 2. We're all following?
Yeah. So
Perfect.
you're solving for the x coordinate on that curve.
On that curve, exactly. So let's go ahead and do that. So x is equal to what?
Negative 1.
Negative 1/2. Perfect. Okay.
And the y prime equals negative 2 earlier, was that the slope?
So this was the tangent line. The tangent line will have a slope of negative 2. We only really care about the negative, or where the, let me repeat that. We only care about what the slope is of the tangent line. We don't care about the y-intercept as much. All right. So now we have the x-coordinate of where the curve has a slope of negative 2, just like the tangent line. All right, so perfect. So now we have to figure out what k is, though. We found where x is, so how are we going to solve for k? If we plug in everything into our function right now, we could plug in our new x, we know where this x value is, into this function, and we get 2 times negative 1/2 squared, but we still have 2 unknowns. We have a k and a y. So what are we going to do? We can't find k because then we'd be done, so we're probably going to have to find y. How can we find y in this curve?
So x to 0.
Not exactly. I'm not asking for the y-intercept. I'm just asking for the y-coordinate where the x-coordinate is negative 2. Or negative 1/2, sorry. At this point, x equals negative 1/2. What should y be? How'd you get 2?
Oh no, 3. Because you plug it into the tangent.
Yeah, you plug it into the tangent. Yeah, so let's go ahead and do that then. I'm going to write it all the way out. Because it should be equal to exactly on that tangent. Remember, this tangent line, if we made a quick little sketch, I can make my sketch kind of neat though. If I made a quick little sketch of what's happening in this problem, I have a tangent line.
Wait, should we draw that?
I think it would help us. We have a tangent line that came up at, let's go ahead and graph that tangent line. The tangent line was at, our equation was negative 2x plus 2. So I go up 2, 1, 2, that's my y-intercept, and a slope of negative 2 means I go right 1, down 1, and then make a line that goes through here. So my tangent line, we'll make red be tangent, look like that. I knew that my x-coordinate is on the curve. Remember, we solved for the x-coordinate of the curve, and that's at negative 1/2, which means if I come over here to negative 1/2, I know that this point is both on the curve and on the tangent line.
Wait, what were your first 2 points, Mr. Snow? Like, how did you get that?
So I'm just graphing this line right here, y equals negative 2x plus 2. So I had the y-intercept, I graphed the y-intercept first, came up 2 for my y-intercept, and then using the slope of negative 2 means I go right 1, down 2. The rise is negative 2, the run was 1.
Oh, I see. Okay. Because on that one, they just give you the slope, so you have to figure out what rise and run in order to graph.
Right.
Or you could just, if you know what the slope of negative 2 looks like, you could just do that too.
Yeah, but you do have to be exact. You can't just approximate a negative 2 slope.
Okay.
What if my graph in the test is ugly?
That should be fine. I don't think they really care about what your graph looks like as long as you can still get the correct answer. They're only really caring about if you can find k. And the graph right now is only used as a tool to make sure we know what's going on in this problem. You don't have to use this tool. So,
When you were in high school, did you take AP Calculus?
AP Calculus was not offered at my high school.
So what did you take?
I took normal calculus. And as I think we talked about this in our class before, it's kind of a waste. It's a college level class, but you don't get college level credits.
But it was still so it was still really hard.
It was not nearly as hard as an AP class, no. The pacing for us is much more intense, and we learned a lot more than what I learned in my high school career. So let me repeat what's going on here. We have this tangent line. We know that that's a tangent line, and we're trying to find the x-coordinate of the curve that has the same slope. And we know that it has the same slope at this point, which means the slope, if we can sketch it, I'll sketch it in blue, it touches at this point but nowhere else. We know our curve is 2x squared, which means it's a positive quadratic. So the positive quadratic will come down and hit at this point but nowhere else. And maybe it'll come up somewhere like this. It just barely touches at that point. And at that point, this curve has a slope of negative 2. Because of the uniqueness of what we found, we can actually plug in this negative 1/2 into the equation for our tangent line because they share the same point in common. So if we plug in negative 1/2 into our tangent line, we should find the y-coordinate that this point is at. Remember, we need to find the y-coordinate in order to plug in both y and x to leave only one unknown and then solve for the unknown. So here we go. We're plugging in. Our equation was right here, y equals negative 2x plus 2. I can recopy that down. Y equals negative 2x plus 2. And I'm plugging in negative 1/2 in for x. So I have y equals negative 2, and here I go. I'm plugging in that x plus 2. So this was negative 1/2 because I had this negative 1/2 come into here. All right, so y is equal to, what's negative 2 times negative 1/2? Shout it out.
1.
1. And I still have my plus 2. Therefore, y is equal to 3. Okay, are we done?
No.
So you
No.
need to plug that in.
Yeah, now I have to plug that in. Maybe I should make this y equals 3 above, so I have some room. Y equals 3. We have an x coordinate. We have our x coordinate. We have our y coordinate. Sometimes problems won't require this much information. In this case, where you're solving for k, you do need both x and y. So plugging into our original curve function again to solve for k, here we go. And if I had room, I would do 4 columns. This is going to be my final column down here. So we're talking to our curve again. Y equals 2x squared plus k. And we're going to plug in our x and our y. So plugging in, we get, I'm going to rewrite the problem, giving us room to plug in. Come on now, pen.
Excuse me, this will.
So y was 3, x was negative 1/2, negative 1/2. Again, if you didn't know where those came from, you can add it to your notes. You can say, well, this negative 1/2 also came down here. The y equals 3, that went right here. Negative 1/2 squared, shout it out. 1/4. 1/4 times 2.
1/2.
So we're going to subtract the 1/2. 3 minus 1/2. 2 and 1/2.
Why would you subtract it? Wouldn't you add it over?
So right now we have a positive 1/2 plus k.
Oh, my bad.
Therefore we found k. And we should box our answer.
And that's the whole point? Like we're done?
And we just found it. Because the question was asking, what is k? K is 2.5. That is the answer. Alright, so backing up, because this is all we're doing, and then we can write our summary. It's going to give us, almost every single time, a curve, f. It's going to give us a line that's tangent, and then it's going to ask us some information. Sometimes it'll ask us, what is the x value? In which case, we could have stopped right here. Maybe it's asking for the y value. We could have stopped right here. This is the biggest problem that I know of in my limited experience. I'm still new to this too. The k means we have to go 4 different steps in order to find k.
So when you're solving for y, what is that y? That's the y on the tangent line?
That is the y on the tangent line and the y on the point of the graph right here. It's the same
Because
point.
they share the y.
Because, yeah, it shares the same point. It shares the y, shares the x.
Wait, so then also with the x? So the x is for the curve and the tangent?
Yes, that x is for the curve and the tangent. So generally, your procedure will always look something similar to this, where you start with a tangent line, find out what your slope is, and then plug that slope into your curve after taking the derivative.
Curve and the tangent.
You literally take the derivative of the tangent, take the derivative of the curve, set them equal to each other, and find out as much information as the question is asking. That's all I have for us. All right, do we have questions?
I feel like I just need to try something.
All right, I would like us to write d dx or f prime maybe. Maybe I should do that in red. Whenever you see the word tangent, automatically write that right next to the question. That way you know you have to find an f prime. The curve, make sure you know that that's the function that we're actually after. The blue curve, that is a real function, and we're finding a line tangent to that function at a certain point, and it's usually asking where that point is. Okay, that concludes the notes. You guys want to say goodbye to Sophia or hello?
Bye, Sophia. Bye.
All right, bye.